Good morning, students. We have to start the chapter real numbers. Okay, so we have to start the practice set 2.3. Question number first. State the order of the surds given below. Okay, here the students, some of the questions are given. These are the irrational numbers and these are the surds. Okay, we have to find the order of the surd. Okay, so students, you just understand here. Here is the cube root of 7. 7 is a radicand and the 3 is the order of that because it's a cube root, and this is the sign is called the radicand sign. Okay. Okay, students, so this is the cube root of 7, means the order of the surd is a 3 because it's a cube root. In second example, fifth root of 12. Fifth root of 12, radicand is 12 and their order is 5 because it is the fifth root of 12, so the order is 5. Another example, fourth root of 10. So obviously the order is 4. Okay, and similarly here only the square root is given in the square root of 39. There is no number shown here, means is the square root. Square means 2, so the order is 2. Okay, you have to find like that. Okay, question number second. State which of the following are surds. Okay, state which of the following are surds. We have to given a question, so these are the some of the surds are given. We have to just simplify it and we have to just find that which are surds or not. Okay, so here the students, first example number first, third and the sixth are surds because the radicand. So first we have to go to the example, cube root of 51. Cube root of 51. Here the students, 51 is a positive rational number. Positive rational number because in radical sign, and is greater than 1. And the 51 is not the perfect cube root of 3. 51 is not the perfect cube root of 3. So we have to call these are the surds. Okay. We have to see another example. Fourth root of 16. Fourth root of 16, students, here is not multiplier, is the fourth root of 16. His number is given. So we have to write down like 16 into bracket raised to 1 upon 4. So we have to find so 16 is a perfect fourth root of 2. Okay, 16 is a perfect fourth root of 2. Okay, so we have to write down 2 raised to 4. 2 raised to 4. Okay, we have to simplify it. It's 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, and 8 2s are 16. Okay, so perfect. So the 16 is a perfect fourth root of 2. We have to say that like that. Okay. So 2 raised to 4, you have to write it like that. And here to just simplify it. So 4 is cancelled. Your answer is 2. Okay, these are the indices. And we apply the rules of indices. Bracket. Okay. So which is not a irrational number. So after simplification, fourth root of 60, we got the answer is 2. So 2 obviously is a positive number. Positive rational number, so is not a irrational number, so is not a irrational number, so is not a surds. Okay. Okay. Next example, root of 256. Root of 256 means is their order is a 2. So 2 we have to write down like that in the bracket. 256 raised to 1 by half. So if you find 256 is the perfect square of 16. You know the 16 to 16 We also got the 256. So we have to write down like that. 16 raised to 2 into bracket 1 by half. Okay. Apply the indices rule. So 2 is cancelled. Your answer is a 16. So which is not a irrational number. Okay. So root 256 is not an irrational number because after simplification you got answer 16. So is not a third. Okay, next example is the cube root of 64. Cube root of 64. So we have to write down like 64 into bracket 1 upon 3. Okay. So the 64 is a perfect cube root of 4. We have to simplify 4 into 4 into 4. 4 4s are 16 and 16 4s are 64. So we have to write down like that the 4 raised to 3 into bracket 1 upon 3. Apply the indices rule. So the 3 get cancelled. Your answer is 4. So obviously 4 is not an irrational number and these are not the surds. Okay. Okay, question number 3. Classify the given pair of surds into like surds and unlike surds. Okay. So example number first is given root 52 and 5. This is the multiply 5 into root 13. Okay. So we have to find that. Okay students, what is the root 52 into 5 into root 13? Okay, so first we have to given the surd root 52. Root 52. We have to find the factors of 52. So into square root of 4 into 13. 13 4s are 52. We have to find the factors when the one number should be the perfect square. So we have to again simplify it. So root 4 into root 13. So root 4 is a perfect square of 2. Perfect square of 2 and into 13. So 2 into 13 is your answer. We can't simplify again because not to find the factor of 13. So another number is so 5 into root 13 and 2 into root 13. Here the students 2 into root 13 and 5 into root 13 in the both the surds. Radicand 13 and 13 are same. Okay. When the radicands 13 and 13 are same, so we have to say that these are the like surds. Okay. Okay. So here's another example. 4 into root of 18 and 7 into root of 2. Okay. So first surd 4 into root of 18 we have to find the factor of 18. So 4 into root of 9 2s are 18. Again simplify 4 into root of 9 into root of 2. Separate it squares roots and 4 into so cube root square root of 9 is a perfect square of 3. So into root of 2. So 4 3s are 12. 4 3s are 12 into bracket root 2. So the 12 root of 2 and a 7 root of 2 are like surds because here the radicand is a 2 and 2 both are same. So we have to call a like surds. Like surds depend on the comparison when the radicands must be similar होने चाहिए यहाँ पे. Okay. Okay, so third example, root 68 and 5 root 3. So root 68 we have to simplify it. So we have to write down the square root of 4 into 17. 17 4s are 68. Separate the roots. Square root of 4 into square root of 17. So square root of 4 is 2 because perfect square. Into bracket square root of 17. Okay, we can simplify it. So second 5 root 3 we have to just compare. So 2 root of 17 and 5 root 13. Here the radicand is a 17 and 3. These are the difference. Okay, and their orders are equal. Students, listen. 2 into root 17 is not an order, is a multiplier, and 5 into root 13, these are the multiplier. Order is a 2. Square root and square root are both the same. These are the multiplier, 2 and the 5. Order is equal, but the radicands are different. So these are the radicands are different. So we have to say that these are the unlike surds. Okay. Another example, 5 root 5 and square root of 75. We can't simplify it. We simplify only the square root of 75. So we take the number square root of 75 is equal to. So we have to find the factors of 75. So square root of 25 into 3. 25 3s are 75 is equal to. Separate the square root of 25 into square root of 3. Square root of 25 is a 5 into root 3. Okay. So the first surd is a 5 root 5 and a 5 root another surd is a 5 root 3. Here the order square roots means the order is the same, but the radicands are different. These are the 5 and 3. These are different radicands. Okay. So we have to say that these are radicands are different. So these are the unlike surds. Okay. Okay, students. Question number 4. Simplify the following surds. Simplify the following surds. Here the students, simplify means surds are given. These are the surds are given. You have to just simplify means find the factor of that. So root of 27. So you have to find the factors are the 9 3s are 27. Okay. When you have to find the factors, so one number should be the perfect square. We have to just try it. So here the students, so 9 3s are 27. So we have to just again simplify it. Square root of 9 into square root of 3. So square root of 9 is a perfect square of 3 into root 3. So we can't simplify in. So this is the simplification of that. We can't simplify. So 3 root means root 27. Their simplification is a 3 root 3. Okay. Another example, square root of 50. Square root of 50. Again we have to find the factors of 50. So square root of 25 into 2. 25 2s are 50. Okay. Again separate it. Square roots. Square root of 25 into square root of 2. So square root of 25 is a perfect square of 5. Okay. Perfect square. So the 5 into 5 means 25. Okay. So into 5 root 2. So simplification is the 5 root 2. Okay. Similarly, another example, root 250. Square root of 250. Again, same process apply. Find the factors. The square root of 250 are the 25 into 10. 25 10s are 250. Okay. So again, just separate the roots. Square root of 25 into square root of 10. So here the students, square root of 25 is a perfect square of 5 into square root into root of 10. Okay. We can simplify this. If we simplify root 10, so we got the answer in the square root of 5 into 2. Okay. Means 5 into 2. There is no perfect square like that. So the last answer is your only the 10. Okay. So we have to write down the 5 into root 10. So what do we say that? If you find factors, any one number should be the perfect square. Like a 25 is the perfect square of 5. 9 is the perfect square of 3. 25 is the perfect square of 5 like that. Okay. Another example, square root of 112. To find the factors, Square root of 16 into 7. 16 sevens are 112. Simplify it. Separate the roots. Square root of 16 into root of 7. Square root of 16 into root of 7. So 16 is the perfect square of 4. So 4 into root 7. Another example. Square root of 168. So square root of 4 into 42. 14 fours are 168. Separate it. This roots. Root 4 into root 4, 142. So root 4 is the perfect square of 2. So root in the square root of 42. We can simplify it. Okay. So the simplification is 2 root 42. Okay students, so this is the methods we have to apply to solve this example, and we have to solve very easily. Thank you.